Precision etiquette.
In a refrigeration system, heat is rejected by A. Latent heat of condensation in the condenser. B. Latent heat of vaporization in the evaporator. C. Latent heat of vaporization in the condenser. D. Latent heat of condensation in the evaporator.
A. Latent heat of condensation in the condenser.
The condenser is where the refrigerant is condensed, rejecting heat, and the evaporator is where the refrigerant is vaporized, absorbing heat.
In a refrigeration system, where does the refrigerant change from a low-pressure superheated vapor to a high-pressure superheated vapor? A. Compressor. B. Condenser. C. Metering device. D. Evaporator.
A compressor.
The compressor adds pressure and temperature to the refrigerant vapor.
The main function of an expansion device is to A. Subcool the refrigerant. B. Superheat the refrigerant. C. Meter the refrigerant. D. Evaporate the refrigerant.
C. Meter the refrigerant.
The expansion device meters the refrigerant into the evaporator, and also creates the pressure differential between the high and low side of the system.
The main function of a receiver is to A. Meter the refrigerant. B. Reject heat from the system. C. Store excess refrigerant. D. Absorb heat from the system.
C. Store excess refrigerant.
A liquid receiver is used to store excess refrigerant after it leaves the condenser. It can also be used as a storage device to pump liquid into if the system requires repair.
How does a technician determine whether or not there is liquid refrigerant leaving the evaporator? A. Checks the amp draw of the compressor. B. Feels the suction line to see if it is cold. C. Calculates with the evaporator superheat. D. Takes a low side pressure reading on the system.
C. Calculates what the evaporator superheat is.
The only way to calculate evaporator superheat is to take a evaporator pressure reading and convert that to a temperature. That temperature can then be subtracted from the evaporator outlet temperature to determine evaporator superheat.
Which of the following is not true about refrigerant? As it enters it comes directly from the compressor condenser. A. It is superheated. B. It is subcooled. C. It is in the form of a vapor. D.
B. It is subcooled.
The refrigerant vapor enters the condenser as a superheated vapor from the compressor. The refrigerant is subcooled at the end of the condenser.
Any additional heat added to the refrigerant after its 100% saturated vapor condition is called A, B, C, D. Heat of compression. Latent heat. To superheat. Superheat.
D. Superheat.
Any additional heat added to the refrigerant after its 100% saturated vapor condition would be considered sensible heat, and can be measured as an increase in temperature with a thermometer. Heating the vapor temperature above its boiling point is then considered superheat.
Most of the heat absorbed in the low side of a refrigeration system is A. Heat of compassion. B. Sensible. C. Latent heat. D. Defrost heat.
C. Latent heat.
When a refrigerant changes state, it absorbs or rejects latent heat. During this phase change, the majority of the refrigerant's potential to exchange heat energy is realized.
If a technician subtracted liquid line temperature from high side condensing temperature, he would be calculating A. Subcooling. B. Heat of compression. C. Superheat. D. Refrigerant flow.
A. Subcooling.
The only way to calculate condenser subcooling is to take a high side pressure reading and convert that to a temperature, and subtract the condenser outlet temperature from the condensing temperature to determine condenser subcooling.